Welcome back. This is where our local assistant finally stops having amnesia. Up to now, every call into Ollama has started from a blank slate. No history, no profile, no idea who you are or what you asked 30 seconds ago. In Part 20, we close out Phase 4 by layering in real memory, sliding context windows, rolling summaries, durable user facts, and vector search over past chats, all stored locally in SQLite. Before we build anything, let's be honest about why this matters. A stateless model tells you it's nice to meet you, Laszlo, and then asks your name again on the very next turn. It drops the 5-stack traces you just pasted the moment you reload the tab. It can't recall last week's database decision, and it greets you every morning in the same stiff corporate voice, no matter how many times you've asked for terse answers. Each one is a small paper cut, and together they shatter the illusion that there's an assistant on the other end at all. The fix isn't one giant memory blob, it's 3 layers, each with a different lifetime. Short term is just the current turn plus the last handful, sitting in line in the prompt where the model already looks. Midterm is a rolling summary of this session, so you keep the gist without paying for every token. And long term is the durable stuff, who the user is, where they live, what they run, kept in a profile in a vector DB, retrieved only when relevant. To back those layers, we don't need anything heavy. 3 small SQLite tables do the job. Messages holds the raw turn-by-turn log, indexed by session and time, so pulling the last N is cheap. Summaries is 1 row per session, rewritten as the conversation grows. And user facts is the durable key-value store that survives across sessions. 1 file on disk, no daemon, full ACID, and it'll happily hold 100,000 messages on a Pi before you even think about Postgres. Short-term memory is the easy win. Just keep the last N turns verbatim and feed them straight into the prompt. Add message appends a row with a Unix timestamp, and recent messages pulls the tail in descending order, then flips it back so the model reads them oldest to newest. 10 is a safe default. If you're on a tight context window, drop it to 6, and if you've got room to breathe, push it to 20. Anything older than that window is what we'll hand off to the summarizer next. And that handoff is exactly what this next layer does. Every 10 turns or so, we grab the existing summary, pull the recent messages, and ask the model itself to fold them into 10 sentences or less, drop the chit-chat, keep the facts. Then we upsert it back into a summaries table keyed by session. It's roughly 200 tokens of generation, runs in the background, and gives you a compact midterm memory the model can carry forward indefinitely. Summaries handle the conversation, but they still expire with the session. So on top of that, we run a second pass that pulls out stable facts, your name, your location, what you're working on, and stores them as key value rows tied to the user, not the session. The prompt is deliberately strict. Skip transient stuff, omit key value lines, nothing else. Parse, insert, done. From here on, every future system prompt can quietly inject these facts so the assistant actually knows who it's talking to. And this is where all 3 layers come together. Before every call, we pull the user's facts from SQLite, grab the rolling summary for this session, and stitch them into a single system prompt. Long-term memory on top, midterm context underneath. Then we tack on the last 10 raw turns for immediate flow, and finally the new user message. The model itself is still stateless, but from its point of view, it now remembers you. But facts and summaries only get you so far. What about that Postgres decision from 3 weeks ago? That's where vector recall comes in. We reuse the Chroma collection from Part 12, embed every message as it goes by, and tag it with the user and session. Then recall, past runs a similarity search scope to this user, pulls the top 3 hits, and we drop them into builder messages right alongside the facts and the summary. Now your assistant can actually answer, what did we decide last week? Now, the moment you start remembering things, you're storing personal data. So let's be deliberate about it. 5 rules. 1. Filter out API keys, tokens, passwords before insert. If a user pastes a secret by accident, don't be the system that immortalizes it. 2. Stamp facts with created at and a TTL because Moving to Berlin in March shouldn't haunt them in 2027. 3. Ship a forget command. 1 CLI call, delete by user ID, GDPR-friendly and trust-building. 4. Always scope vector queries with a where clause on user ID and actually test it with 2 users. And 5. When someone asks, "What do you know about me?" just dump the table. Transparency beats creepy every time. Privacy aside, let's talk about the bugs that will actually bite you. 5 traps. Contradicting facts. The user moved from Paris to Berlin, but your retriever still serves Paris because it scored higher. Fix it with updated EAD and always prefer the latest. Summary drift. Summarizing a summary of a summary erodes the original. Once per session, regenerate from raw messages. Infinite history growth. SQLite shrugs, but your vector DB and embeddings will eat real disk. Archive yearly. Cross-user leakage. Forget the user ID filter on a vector query once, and user A reads user B's life. And PII in summaries. Even if you scrub inputs, the model will happily paraphrase a secret right back in, so rejects the summary too. With the traps mapped, here's your homework for tonight, and resist the urge to over-engineer. 4 things in order. Run schema.sql and wire add $message plus recent messages into your chat loop. That's persistent history in about 30 lines. Then a rolling summary cron every 10 turns, collapsing 100 messages down to 10 plus a summary. Then a user facts table, extracted post-session and injected into the next system prompt. That's where the "it remembers me" magic lives. And finally, a forget command. Build it first, before you have any real data to lose. Now, before you go bolt memory onto everything that moves, a counterweight. Memory costs storage, complexity, and privacy debt, and there are 3 situations where Stateless genuinely wins. One-shot pipelines, translation, summarization, classification. There's no conversation to remember. Each call stands alone. Public or anonymous interfaces like a website demo or a museum kiosk, where remembering the previous user is actively wrong. And strict regulated domains, healthcare, finance, legal, where persistent user data drags you into retention rules you may not want to own. Sometimes no memory is the legally safe default. So with that caveat noted, let's pull the whole part together. 5 things to carry forward. Memory is layered: short-term verbatim, mid-term rolling summary, long-term stable facts. SQLite with 3 tables is genuinely enough. No Postgres, no cloud, no daemon. Let the model summarize itself every 10 turns to keep context cost flat. Inject user facts as system prompt. That's what makes turn 1 feel personal. And build forget on day 1, because trust is the actual killer feature here. And here's the page worth bookmarking: 12 patterns that cover 90% of what you'll actually build. Left column is your storage and write path. 3 tables, the summarizer, the prompt builder, and the non-negotiables. Always scope by user ID, always scrub PII before insert. Right column is the read and lifecycle side. Rolling summaries, sliding window of recent messages, fact extraction after each session, vector recall when you need older context, forget as a first-class verb, and updated DAR at so the latest fact wins. Screenshot it, pin it next to your editor. And that closes phase 4. Your assistant remembers, short-term, long-term, and semantically. Next up in part 21, we stop trusting vibes and start measuring logs, latency, token cost, and error rates. 5 small dashboards so when something breaks at 3 a.m., you're reading a graph instead of guessing. See you in phase 5.